This is question 13a in the 2017 HSC Extension 1 paper, and here we have a particle moving along the x-axis in simple harmonic motion centered at the origin. Now we're told that when x is 2, the velocity is 4. So that's a positive displacement and a positive velocity. And we're also given that when x is 5, the velocity is 3. So that's another positive velocity for a positive displacement. So since we're not told at what time any of this occurs, we can just make it convenient for ourselves, and we'll note here that for a sine curve, we'll immediately encounter a positive displacement and a positive velocity. So let's base the displacement function on a sine curve, and we'll say that we hit x is 2 at time t1 and x is 5 at time t2. So what we have here is at time t1, x is 2, and the velocity dx dt is 4. So now, since we've based our motion on a sine curve, let's formalize that and say that the displacement function is a sine nt. So now we have the velocity as the derivative of that, which is na cos nt. So at time t1, we have a sine nt1 is 2, and na cos nt1 is 4. Now, since sine squared plus cos squared is 1, we might start by squaring both sides of both of these equations, and then to be able to use the identity, we also need to multiply the first equation through by n squared. And now we can just add both of the resulting equations together simultaneously, and that gives us this very tidy result. And now we can do the same for the information we got for time t2. And so here we end up with 25n squared plus 9 is n squared a squared. So now we have two expressions that are both equal to n squared a squared. So clearly they're also equal to each other. So let's put them together and tidy it up. And we'll end up with n squared equals 1/3. And so n equals 1 on root 3. So since we set our displacement function to x is a sine nt, we've just worked out that it's actually x is a sine t on root 3. Now we need to find the period of the motion. And the period of a sine curve is 2 pi, right? So right here at the end of one period must be where t on root 3 is 2 pi. And therefore, the period of the motion is 2 pi root 3.